So, hello dear students. Now we would move ahead in this chapter number first, that is the chemical equation and the reactions, where we were discussing the examples related to the redox reaction. We have read about the types of reactions. So let's discuss the redox reaction in brief again now, because it's very important from the exam point of view. Redox means reduction and oxidation, where the reduction and oxidation are taking place simultaneously would be called as the redox reaction. Reduction means the addition of hydrogen or the removal of oxygen would be called a reduction, and oxidation means addition of oxygen or the removal of hydrogen would be called as the oxidation. At the same time, you have to know about the oxidizing agent and the reducing agent. Oxidizing agent means the substance which oxidize others but gets reduced itself are known as oxidizing agent. Mean the substance which do not oxidize, rather the substance which oxidize others, the substance which oxidize others but itself it is being reduced would be called as the oxidizing agent. At the same time, reducing agent means the substance which reduce others but gets oxidized itself would be called as the reducing agent. Like in this example, if you would see here, oxidation and reduction taking place simultaneously. How? Look here, copper oxide just converting into copper. So removal of oxygen here. Here oxygen was there, here is the removal. So where there is removal of oxygen would be called as the reduction. So here reduction is taking place. At the same time, there is, you can see, addition of oxygen here. So where there is addition of oxygen would be called as the oxidation. Now I'm asking, what is the oxidizing agent here and what is the reducing agent? Which substance is being reduced and which substance is being oxidized? That you have to answer also. Here first question is reduced substance. Number 2, oxidized substance. Number 3, oxidizing agent. Number 4, reducing agent. So these sort of questions we have already discussed also. Let's discuss this question more. So you have to answer these 4 questions. Which is getting reduced there? Reduced substance. Which is getting reduced? CuO is getting reduced. CuO was alone here. Here there was oxygen there. Now it is removal of oxygen. So it means CuO is getting reduced. So CuO means copper oxide is getting reduced. Which is getting oxidized? So where there is addition of oxygen. So here you can see addition of oxygen. So means H2 is getting oxidized here. What is the oxidizing agent then? Oxidizing agent means that oxidize others but reduced itself. So which one is oxidizing others? Like if you see CuO is oxidizing H2 because CuO is giving oxygen to H2. So means CuO is oxidizing H2 but itself it is reducing. Okay, so oxidizing agent means the substance which is oxidizing others, but itself it is reducing. Okay, so would be called as the oxidizing agent. So this is the oxidizing agent here. CuO is oxidizing agent. Why it is oxidizing agent? Because it is oxidizing hydrogen. So that is why it is giving oxygen to hydrogen, na? So that is why it is oxidizing hydrogen and itself it is being reduced. So CuO would be called as the oxidizing agent. At the same time, reducing agent means the substance which is reducing others. The substance here which is reducing others but itself it is oxidizing. Here if you would see, hydrogen is reducing copper oxide because hydrogen is taking oxygen from the copper. So that is why hydrogen is reducing copper oxide. So hydrogen is reducing copper oxide but itself this hydrogen is getting oxidized. Hydrogen is reducing this but itself it is being oxidized. So the substance which is reducing others but itself it is oxidizing would be called as the oxidizing agent. So which one is oxidizing agent here? That is the hydrogen. So hydrogen would be called as the oxidizing agent here. Okay, just note this also down, then we will move ahead. So one more question you have to answer. Let me give you one more. We have already discussed this sort of questions. Okay, so let's study in a brief again. Okay, so like the question is here, this you have to do on your own. Okay, Fe2O3 plus aluminium and you are getting here iron plus Al2O3. Okay, so which is being reduced, which is being oxidizing agent as well as the reducing agent, you have to answer here. So this is the first question here. We have already discussed, I think, this sort of question. Okay, so in a brief you have to answer the question. Okay, are you getting this? Okay, so this was the concept of the redox reactions, but this is the earlier concept of the redox reaction. This is the earlier concept of reduction and oxidation which you are to study in the 10th class. But when you would go into the higher classes like in the 11th and 12th classes, there you would not study this earlier concept about the redox and reduction. Rather, there is some modern concept of reduction and oxidation. There the definition of reduction and oxidation is changed now. Okay, so that would be the modern concept. So in modern concept, let me tell you about the modern. This is the earlier concept of the redox reaction and the earlier definition also. Okay, so let's discuss the modern concept of reduction and oxidation that you would study. Okay, you would study this in your classes ahead in 11th and 12th. It's not important here, but you should know about this also. This is the earlier concept, but in the modern concept, when there is gain of electron, this is called as reduction. Are you getting this? In the earlier concept, there is addition of hydrogen and loss of oxygen would be called a reduction. But in the modern concept, gain of electron, where there is gain of electrons, we call this as the reduction. Okay, and where there is loss of electron, we call it as oxidation. So this is the basic difference between reduction and oxidation. So where there is gain of electron is reduction, and where there is loss of electron is oxidation. So this is the modern concept which you would study in the classes ahead. Are you getting this? Very good. Now let's discuss the effects of oxidation in our daily life. That's very important topic from the exam point of view. Okay, just note this down. Now we would study the effects of oxidation in our daily life. So now we would study the effects of oxidation in our daily life. If you would see, there are basically two effects of oxidation which you would see in your daily life. First one is the corrosion of metal, and second one is the rancidity of food. Corrosion of metal means here the metals are slowly eaten up, and gradually they are eaten up by the action of air. Okay, if you keep the metal outside in air, it would slowly it would be eaten up, or gradually it would be eaten up by the action of air on it. Okay, so this we call as the corrosion of metal. So the best example of corrosion of metal is the rusting of iron. Here you would see rusting of iron is the example here of the corrosion, because the corrosion of the iron metal is called the rusting. Okay, there are other metals also, steel objects are also there which gets corroded, okay, by the action of air, but the best example of corrosion of metal is the rusting of iron. Okay, so in case of when the iron metal is corroded, we call it the rusting. You would see the brown colored layer over the iron objects. This is due to the oxidation of iron. Are you getting? Second one is the rancidity of food. When your the food gets means spoiled, okay, we call it the rancidity of food. It is also by the action of air on it. Okay, so let's study the corrosion in detail. Corrosion is the process in which metals are eaten up gradually by the action of air, moisture, or a chemical on the surface of the metal by the action of air. If they are slowly eaten up by the action of air, okay, that is called the corrosion. And the corrosion weakens the iron and the steel object and the structures such as railing, cars. So these all the structures are weakened up, and the life becomes shorter also. Their life also become shorter. It cuts shorts their life also. Okay, this is due to the corrosion. So corrosion, the effect of corrosion is it weakens the iron and the steel objects also. Not only the iron, but the steel objects are also affected by the corrosion. Okay. The best example of corrosion is the rusting. Rusting of iron metal is the most common form of corrosion. Okay, so this is the formula of the rust: Fe2O3 into Xs2, the layer over the iron objects, the brown colored layer. This is the formula. That is the rust. The formula for rust is Fe2O3 into Xs2. Okay, so rusting is the unwanted oxidation of iron metal which occur in nature on its own. So it is the unwanted oxidation, because we do not want the rusting of an iron object. Rather, it is an unwanted oxidation. unwanted oxidation of iron metals, which occur on its own in the nature. Okay. And the rusting of iron is also, it is not only the oxidation, it is also the redox reaction. So reduction also would take place here. So rusting of iron is a redox reaction. Here you would see iron plus oxygen in with the help of the moisture, that is H2O, gives Fe2O3 into XS2. So here you would see the oxidation of iron, and at the same time there would be the reduction of oxygen also. Okay, so reduction and oxidation are taking place simultaneously. That is why rusting of iron is also an example of redox reaction. Okay, so this is all about the corrosion. Now we would study how to prevent the corrosion. Okay, so there are different methods also. By that you can prevent the corrosion also. Okay, just note it down. And now we would study how to prevent rusting. Okay, we can prevent the rusting or the corrosion of the iron metal, number one, by oiling, painting and greasing over the surface. If you just paint over the surface, you can prevent the rusting somehow, because you have painted there on the surface of the iron metal. So the rusting would not be possible after that. Okay. Second, one more method is there, that is galvanization. Galvanization means that is the coating of zinc. If you are having a coating of zinc over the iron metal, so that is also called the galvanization. Again, you can prevent the rusting from by that. Third one is the alloying also. But alloying is mixing the metal to metal and non-metal to metal, etc. So this mixing is called the alloying. Means you are mixing with iron. Okay, that would become an alloy. Okay, so by alloying also you can prevent the rusting. Okay. Fourth one is by connecting to a more electropositive metal, because if you are connecting the iron to a more electropositive metal, so the more electropositive one metal would be corroded first, and later this one. So this is how again you can slow the process, or you can prevent the rusting. Okay. The next concept that we are going to talk is the rancidity. Rancidity means the oxidation of the food. Okay, simply the condition produced by aerial oxidation, means the oxidation from the air. Okay, the condition produced by the aerial oxidation of fats and oil in food, marked by the unpleasant smell and the taste, is called the rancidity. Means something, if your food gets spoiled, you keep the food in air, so there and having the food is having oil also, so the fat that is in the oil would be reacting with the oxygen that is in the air, and your foods your food gets spoiled. That is called the rancidity. Then you would have the unpleasant smell there, and the taste is also something different. So that is also called the rancidity. Okay, so how to prevent the rancidity? We can prevent the rancidity also by adding the antioxidants to the food containing oil. Suppose the food that contains oil, if you are adding their antioxidants that you can find in the market, there like some antioxidants are there, like BHA and BST. BHA means butylated hydroxyanizole, and BST is butylated hydroxytoluene. So these are two antioxidants that are commonly used there. So we just add these antioxidants with the food that contains oil. So that is why we can prevent it from the rancidity. Okay. At the same time, you can prevent at home also. We are using the process. The rancidity process can be retarded by keeping food in refrigerator. If you keep the cooked food, if you keep this in the refrigerator, then also we can prevent it from rancidity. Okay. One more method is there, that is keeping away from light. Something you might have seen there, some items that you are getting from the market, that it is directly, it has been written there, keep it away from the light. Why it is so? Because to prevent it from the oxidation. Okay, so keeping away from the light and packaging the fats and oil containing food in nitrogen gas. Suppose you would find the kurkure, etc., chips from the market that contains also oil and fat, but they are packed in nitrogen gas. So inside the packet there is nitrogen gas filled. So this nitrogen gas prevent it from being oxidated. Okay, so that is how you can prevent the food from rancidity. Okay, so that is all for today. Would be discussing some more. Okay, then stay tuned and keep watching. Thank you. Have a good day.